A lot of the same techniques for the transformations of all graphs also apply to reciprocal functions. Main key concept I'm going to focus on here is where the vertical translation is on a reciprocal function. We know that graphs can be translated in the form of HK. H is the horizontal translation. It is going to be grouped with the x. So in this case, being grouped with the x means it will be in the denominator. K is the vertical translation, and it is the part that is not grouped with the x. It is usually attached to the outside either through addition or subtraction, and that's how far up and down that you go. With reciprocal functions, I really focus on the vertical translation because the vertical translation not only helps you find how far the graph goes up or down, but it's really integral in helping you find the horizontal asymptote. Because just like graphs can move up and down, so can asymptotes. So example 3 says graph the function, state the domain and range. So the vertical asymptote is going to be located where the denominator equals 0. So we're going to set the denominator equal to 0, and that will find the vertical asymptote for us. So 1/2 x minus 2, set that equal to 0. So I would just add 2. So 1/2 x equals 2, and then multiply by 2 because 2 times 1/2 eliminates each other, and x equals 4. So that is the vertical asymptote. So I can go ahead and graph that at x equals 4. So I'll draw a dotted line to describe that. And then the horizontal asymptote can be found by looking at the vertical change. And notice there's a +2 that is not grouped with the x. That is the vertical shift. And so I'm going to have a horizontal asymptote across the line y equals 2 right through there. Then to get some of the other points is we're going to do a t-chart. Now the points you want to pick on the t-chart aren't going to be the typical 3, 2, 1, 0, -1, -2, -3 like as I showed you already above. We need to pick a points around the vertical asymptote. So some of the points around the vertical asymptote, and I'm just going to put x's here to highlight them, would be at like 2, 3, 5, and 6, and then some of the very close fractions around that area as well. So I'll start with 2, 3, 5, and 6. So 2, 3, 5, and 6. So when I plug those in, I'm going to have 1 over 1/2 times 2 minus 2 plus 2. So 1/2 times 2, that is going to be 1. So 1 over 1 minus 2 plus 2. 1 over 1 minus 2, that's 1 over -1, which will equal -1, and -1 plus 2 is 1. So when x is 2, then we get y is 1. And then now I'll plug in 3. So when I plug in 3, I'm going to get a 3 there. So that'll be 1/2 times 3, which is 3/2, minus 2. 3/2 minus 2 is -1/2, so this is 1 over -1/2. 1 over -1/2 is -2. -2 plus 2 is going to be 0. So 3, 0. And then we will plug in 5. So when you plug in 5, one half times 5 is 5/2. 5 halves minus 2 is 1 half, so 1 over 1 half plus 2 would be 2 plus 2, which equals 4. And then do it for 6. So 1 half of 6 is 3. 3 minus 2 is 1. So that becomes 1 over 1, which is just going to be 1 plus 2, which equals 3. So I have 2, 1, 3, 0, 5, 4, and 6, 3. So it looks like I just got 4 points there in the rectangle, but remember what these graphs look like. They're hyperbolas, which means they are going to move up and to the right and move up near one axis, one asymptote, and down towards the other. So the graphs are going to roughly look like this. And there you go. There is your hyperbola. And then it asks you to state the domain and the range. So the domain and the range, again, is going to be based upon where are those asymptotes located. So the domain is going to be every point except for x cannot equal 4, because that's where the vertical asymptote is. And the range is going to be y cannot equal 2, because that's where the horizontal asymptote is, and the horizontal asymptote is located there because of the shift of 2 units up. So let's try another one. F of x equals negative 3 over x plus 1 minus 4, and the directions are the same. We're going to graph this and then identify the domain and range. So to find the horizontal asymptote, or excuse me, the vertical asymptote is going to be located at where the denominator equals 0. So x equals 1 is going to be the, negative 1. Try that again. X equals negative 1 will be the vertical asymptote. And then we have a vertical shift of down 4 units for that minus 4 that's at the end there. So I will draw a horizontal asymptote through here at y equals negative 4. So there's my asymptotes. To get the rest of the graph, let's do a t-chart. And we're going to pick some points around the vertical asymptote. So good points to pick would be 2 units to the right of that. So that would be 0 and 1. And we can pick 2 points to the left of that, which would be negative 2, negative 3. So we're going to plug in to our x. We'll have negative 3 over, then let's start by replacing the x with 0, plus 1, and then minus 4. So that would be negative 3 over 1, which is negative 3. Negative 3 minus 4 is negative 7. So when x is 0, y will be negative 7. And then do it again. This time use 1. So negative 3 over 2 is what we're going to come up with. So that's negative 3 halves. Negative 3 halves minus 4 is going to be negative 11 halves, or negative 5.5. And then on the other side, we'll have negative 2, so plug in negative 2. So that'll be negative 3 over negative 1, which is positive 3, and 3 minus 4 equals negative 1. And then one more. We'll use negative 3. So negative 3 plus 1 is negative 2. Negative 3 divided by negative 2 is positive 3/2. And 3/2 minus 4 is going to be 5/2. Excuse me, negative 5/2, negative 5/2. So when I graph those, I'll have 0, 7, so straight down 7. 1, negative 11/2, that's about 5.5. So here's negative 5, so 5.5, about right there. And then negative 2, negative 1, places it right here. And negative 3, negative 5/2, that's about 2.5, places about right there. And that'll give you a pretty good indication what the graph looks like. Through there, and through there. Then we identify the domain and the range, which is still based upon the asymptotes. The domain is going to be x cannot equal -1, and the range is going to be y cannot equal -4.